Okay, so hi, my name is Nagar. In case you don't know, I'm the chapter leader of Georgia, Tbilisi, the country. And my chapter is basically just about data science, machine learning, deep learning, and now visualization. Basically anything with Python, I think. Okay, so we're going to discover, the very basics of Matplotlib, and let's start. Okay, so why is visualization important? I think it's like maybe it sounds stupid, but it's good to, kind of say it out loud that a picture is worth 1,000 words. So when we want to discover some data and we have a lot of it, and just mean and standard deviation, stuff like that doesn't really give us a lot. And sometimes we're presenting to someone who doesn't know coding and doesn't know mathematics. So it's very hard to give them meaningful insights about a data set. So that's why we use visualization. Okay, so by far, I'm sure that you know that Python has a lot of modules about everything, literally everything. So why are we starting with Matplotlib? And you probably heard its name before as well. So why? Why are we going with Matplotlib? And the answer to that is that, first of all, the documentation of Matplotlib is very good, compared to other modules. And Matplotlib gives us complete control over the properties. For example, the color, the labels, the size, and basically every other thing that you can control. Literally, you can control everything. So yeah, that's why we're going with Matplotlib. First of all, if you don't have it installed, just run this cell. And I have it installed so you can see it like that. I don't think it's gonna take a long time in case you don't have it as well. Okay, so the first thing that we need to actually visualize something is to have something called pyplot. And well, it's for plotting, it's obvious. So Matplotlib is library, you know that already, and pyplot, I just explained what it is. And we usually just go over the alias Plt. Of course, it's not, you can name it whatever you want, but that's what we go for. And I suggest you do the same because someone else reading your code would not understand otherwise. Okay, so Plt Subplots gives us the space that we can do stuff in. And it gives us figure and axis. The figure object is basically just the container, the box that everything goes on. And the axis object is, where we can actually visualize, put histograms, violin plots, whatever. Okay, so right now I just created a very empty graph or plot, whatever you want to call it. So yeah, here it is. It's just very basic, 0 to 1, again, 0 to 1, empty. Now we want to put data on it. And this is just for reference, like in case sometimes you forget and just want an abstract of what we're going to cover. We have it all here. Okay, so the first data set is Austin's weather from 2013 to 2018. I'm importing pandas because I'm, opening a CSV file. And the name of our data set is austinweather.csv. So I'm opening that. And I'm choosing the columns date, temperature, average temperature, and, well, I joined it. I think that's fine. Okay, and then the average wind, miles per hour. Okay, let's see what our data set looks like. Cool. We have dates. We have, I just mentioned what we have. This is for miles. This is for Fahrenheit. And our dates is basically daily, as you can see. And let's see how much data we have. We have 1,319 rows and 3 columns. Okay, that's a lot of data. Okay, so here's the thing. To ease our process, what I did was make our daily data into yearly data. And for that, I first converted this column, which is strings basically, into a date time. And after that, I just resampled it, which basically means that from daily to yearly. So we will have 2013, 14, 15, 16, 17, and 18. Yeah, that's basically what I did, and I stored that in summary. And what I was interested at, you can try different things, of course, was how much did the temperature change over the years, the average temperature. So let's see how it looks like now. Oh, I didn't run this. Right. Okay, so I have date stamps here, and I have the temperature over here. So I have both the columns that I need. So that would be the X and Y on my plot. And the first thing that we're going to try, which I think you know that everything that you put dot before is called a method. And yeah, so the first method that we're going to discover is dot plot. So again, I'm creating a new figure and axes, and I'm plotting summary, which consisted of these two. The date bit. Okay, what is your error? Let's see what it is. Did you put... That's very weird. Are you sure there are quotations on, you know, because Y could be a frequency, but if you put quotations, then it will be year. Or maybe you don't have maybe pandas installed, so maybe install that. These are the two I can think of. Okay, so I plotted, okay, cool. So I plotted this, but it looks kind of weird, as you can see. Well, I mean, it kind of worked, but I don't know what's happening. I don't have any labels, and this is a mess. So let's see what happened. What I can do basically is to create a label for my X and Y. The X is the dates, and this is our temperature. So I just basically said plot dot, again, another method that we're using is X label and Y label. And okay, let's run it. Okay, now I know what's happening, but still this is not fitting on my screen, so it's not very good. What we can do is to control, I said that we can control any property, right? So we can control the width and height, and for some reason 6 and 12 is usually what we go with. Either it's 5 or 10 or 6 or 12. Basically all data kind of fixes on that. So that's why I went with 12 and 6. And there we go. Now it worked. I can see the dates here, and I can see the average wind miles per hour. So cool, it works. But again, if you look at the X axes, you can see that, okay, so I have two 2014s here, and my data only has 2013, 14, 15, 16, and 17. So yeah, that's a bit weird. The thing is, when you're plotting something and you're using just lines, Matplotlib just turns it into a continuous value. But we want it to be discrete because it was yearly. Our data is yearly. It's not relating to each other, right? So what we can do is to use a marker. Marker tells us, okay, so this was an actual data that you had, and the other lines, I just came up with it myself based on the other values that you gave me, but the actual data is going to be the thing that we mark. So if I run this, you can see that the O's or dots here, so these are the actual data that we have on our data frame. So these are the discrete values. As you can see, it's from 2014 to 18. And okay, another thing that could be confusing is that why isn't 2013 showing up? Because we had it here on our data set. The reason is that it was exactly like, it was the last day of the year. So Matplotlib just figured, hey, it's probably just 2014 anyway. So that's why. This is technically just the last day of 2013. Okay. Right, it was here. Okay. Okay, I said that we can change the color and it doesn't round it up, but in this case, because we're looking at it yearly, we only had one of 2013. So it just figured, okay, fine, like it's probably just in 2014. That's what the graph says, because the scale is really large, so you can't see it on the plot. But if you did it daily, for example, then you would be able to see it. It wouldn't be round up technically. Okay. Yeah, you're welcome. Okay, so, right. So we can add a title. A title is basically what comes, in the beginning. So someone who's looking at your graph knows exactly what they're looking at. And we can change the color, which is very cool. So I'm not changing anything except this color. So I chose the red. And I'm adding a label, the title label. So it's basically just set title. Okay, now it's red. Cool. And we have the title here, which is temperature versus year from 2013 to 18 in Austin. Yeah, we did, this is legit. So it's cool. Any questions so far? Take that as a no. Okay, so the next data set we're going to explore is Pokemons. Let's see what it looks like. We have a lot of columns. We have different types of Pokemons, type 1 and type 2. We have total, HP attack, defense, SP attack, speed defend, and speed, generation, and legendary. Okay, so now we're going to try to do histograms. Firstly, I just want to compare the total column with type 1 Pokemons, because there's a lot of columns and we just want to do 2D histogram, and histograms are 2D. So that's why I chose 2, type 1 and total. And type 1 are water Pokemons. So I ran it. I stored all the type 1 Pokemons in water DF data frame. And I'm doing exactly the same thing. I'm adding a subplot. First, I'm doing a figure, and my ax is just adding a subplot. And okay, so here I'm saying ax hist, which stands for histogram. And I'm just, putting it against total, as you can see here. Okay. It worked again, but we need some kind of labels and stuff. But it's improved here, which is the distribution of total for Pokemon of type 1. So this is a total, and this is how, the variation is going on. So you can see that most of the water Pokemons are here and here, because that's the highest number of them. And I used 2 things that I need to say here. First of all, it's beans, which is just showing how much how many or how much of something it's on the y-axis. And I use which, and I use ticker here, and a multiple locator, basically, yeah. So I've linked 3 things here that you can check. It's not very complicated, but there's a lot of types that exist. Multiple locator basically puts, well, we're doing it on major locator, which is on the y-axis. So what I did was to take multiplies of 5 appearing here, only 5. So that's why we have 5, 10, 15, and 20. And yeah, so ticker basically just helps us clarify our plot or histogram to someone who's looking at it. So that's basically it. And of course, no one knows all of this by heart. Obviously, that's why there's a lot of articles and of course the official Matplotlib website that you can choose. Okay, so one more thing that I want to discuss here. Let me pull it up. Okay, so it's this website, which is called, so we just compared type 1 water Pokemons, yeah. So this website is data to viz, or visualization. This is exactly like when I'm working, I use this when I want to visualize something. As you can see here, like it basically just gives you everything that you need to know. For example, if you have 2 numeric variables and you want it ordered or not ordered, a few points, many points, it gives you all the possible plots that you can have. For example, we just discovered histograms, right? It, tells you what it does, common mistakes. It has both R and Python gallery, and it has D3.js, which I'm not going to get at. And let's, for example, see the Python gallery. And, well, it has even a tutorial on Seaborn, which is used to make your graph more pretty, basically. That's all visual. Yeah, and it explains what you can do, different stuff, different colors that you can do. And yeah, and it gives you like things that are related to that graph, which is, for example, for distribution. YLM plot, density, histograms, box plot, so on. And yeah, I'm gonna stop recording.